Hello, this is Mrs. Brown, and today we're going to talk about graphing inequalities on the coordinate plane. So, as you recall, when we were graphing equations, linear equations, if they were in slope-intercept form, y equals mx plus b, so a number times x plus the intercept, that in order to graph this, we would start by graphing the y-intercept, which is the constant, the plus b, and then we would use the slope to find another point, so the slope being m. Well, when we start with inequalities, actually the first thing that we do is we graph it. We graph the equation of the line, just like we would if it was a regular equation. So as I look at this, you can see this format that even though this is an inequality sign instead of an equal sign, I have my y-intercept of -1, and I have a slope of 2. So that's my first step. So I'm going to start by putting my y-intercept on. Remember that this is the y-axis and this is the x-axis. And so I'm going to put a dot at -1. A slope of 2 means 2 over 1. So that's 2 up and 1 to the right from that point. So I go up 2 and 1 to the right, up 2, 1 to the right, and so on. Okay. I can also go the opposite now that I have my pattern if I want some more points. Now, here's where things start to get a little bit different. This inequality sign is a less than sign. It's not or equal to. If you remember with the number line, sometimes we had an open circle or a closed circle, depending on whether it was greater than or less than. It was open, it wasn't shaded in, or you had it shaded in because it was or equal to. That's because if y is less than this, it's not included in the answer. So the same thing's true on the coordinate graph, except that we either have a dashed line for less than or greater than, or we have a solid line if it's less than or equal to or greater than or equal to. So if you take a look at this one, this is just a less than, so I have to have a dashed line. So I'm going to connect these points, but I'm going to connect them with dashes instead of a solid line. So dash, 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 dash. Okay. I don't have a ruler, so that's not perfectly straight, but we'll work on that. All right, now the last bit is I have to shade. I have to shade in the direction. So with an inequality, there's a whole region where there's possible points that are going to work instead of just the points on the line. And in this case, because it's less than, none of the points on the line are part of the solution. It's only in the shaded area. So the y's are less than 2x minus 1. So the y's are less than this line. What I found is the easiest thing to do is to use the y-intercept as a reference point. So here's my reference point. So I need y's that are less than this point. So this is at -1. So if I go up, things like 1 are greater than, but I have to have y's that are less than. So if I go down, for instance, -3 is less than -1, so I need to shade underneath. Okay, so I literally just shade this whole region. Now, it's really easy to check to see that you did this correctly. So let's say that I take a point on this side that's in the shaded area, and I can pick any point that I want that's in the shaded area. So maybe I pick this one, which is at 2, -2. Okay, so over 2 and down to -2. And I substitute those numbers in here and see if it comes out correct. So y, I said, was -2. And if I substitute in 2 here, okay, 2 times 2 is 4, minus 1 is 3. Is that statement correct? Is -2 less than 3? Yes. So I know, since it checks out and it's true, that this is in the correctly shaded area. Let's say I pick something like 0 that's not in the shaded area. I should get something that, I shouldn't get something that's true. I should get something that's false because it's not a solution. So if I take a look at that, if I put in 0, 0, let's just take it, it shouldn't work. So I put in 0, and 2 times 0 minus 1. 2 times 0 is 0, minus 1 is minus 1, and it says that 0 is less than -1. Well, 0 is not less than -1 because all negatives are less than 0. So this is false. which means it's not part of the solution set, and that makes sense since it's not shaded in. Okay, let's take a look at another example. Okay, so for this one, let's try one that's an or equal to. So what's the difference? Again, when I start looking at these, I'm going to start like it's an equation. I'm going to graph it the same way I would an equation. So I've got y is greater than or equal to negative 1/2 x plus 2. So my y-intercept is going to be 2, positive 2. So if this is the y-axis and this is the x-axis, I'm going to start with my first point on the y-axis at 2. And then I'm doing a slope of negative 1/2. A slope of negative 1/2 means 1 down and 2 to the right. So from that point to get to the next point, my slope tells me to go down 1 and 2 to the right. Down 1, 2 to the right. Okay, and I can repeat the pattern backwards to find some more points. Now, this is an or equal to. An or equal to means that anything on that line is a possible solution. So that's going to be a solid line because it's going to be included in that answer. Okay, so it looks something like that. Now, the last bit, the bit that's different than what you're doing when you're doing just an equation, is that there has to be a shaded area. So in order to figure that out, I need those y's that are greater than this line. So the y's that are greater than this line. So again, the easiest thing that I find to do is use the y-intercept and think about it. Are the numbers above it greater than, or the numbers below? Well, this is 2. Above it's 3, which is greater than 2. Below it's 1, which is less than 2. And I need y's that are greater. So I'm going to shade above. So again, to recap, use your slope and intercept that you would use for an equation. You start by graphing that. You look at the inequality sign. If it's less than or greater than, you use a dashed line. If it's or equal to, you use a solid line. And then you decide on the shading depending on the region. If you use the y-intercept as your reference point and follow the rule, y's are greater than this, or if it says y's are less than, it's a lot easier to figure out how to do that. Okay? I hope this helps and have a fabulous day.